Hello YouTube, and welcome back to my tutorial on how to program FOOBAR. Today we're going to be talking about control flow, which is basically how to control how your program executes, mostly through conditional statements and loops. So, quick recap of the practice we did in the last episode, where I asked you to write a program that gets two numbers from the user and prints the following: sum of the two numbers, product of the two numbers, integer quotient of the two numbers, remainder, and then true or false that the numbers are equal to each other. This was the solution I came up with here. You can see we've got our main function here, and we've got our return true, as every FOOBAR program needs to have. And I declared integer A and integer B for the two numbers that the user would input. I asked them for the first number. We store that response in A using scan integer. Remember, we got to have the right data type. Enter the second number, store that into B. And then it prints the results here. So this is just the little header here, but I create and store all in the same stroke an integer called sum, which is just A plus B, product, which is A times B, quotient, which is A divided by B, remainder, which is A mod B, and then a Boolean. All of these are integers, but this one is a Boolean because it's true or false. Equal, that is A equal to B, true or false. And then I print all of those, and I make sure to use toString for the type conversion, so sum to string, product to string, etc., including the Boolean, because you can also do a Boolean toString. And then, yeah, end it with return true. So you should have gotten something pretty similar to that. This is a pretty simple program. There's a lot of lines because there's mostly just a lot of print statements and a lot of variables you have to declare, but other than that, pretty simple stuff, especially if you were able to follow along pretty well with the last episode. All right, conditional statements. Conditional statements basically allow your program to respond dynamically to user input. And what that means is that you can have a fork in the road where you say, if the user inputs this, then let's go to this output. But if the user inputs this instead, let's go to this output. And you can have multiple possibilities for what your program will execute. You're not just printing dynamically changing values. You're not just printing variables, but you can actually change how your program operates depending on user input. So there are three different conditional statement types in FOOBAR. The most simple and the one that you kind of need to have for the other two is the if statement. And the if statement, you see that there is a set of parentheses and a set of curly braces. And the curly braces are just to define the scope of the if statement, or what to execute if what's in the parentheses is true. What's in the parentheses is the condition. So it can be a Boolean, or it can just be a condition like A double equal sign B. If A equals B is true, then execute this. There's also else, which, as you can see, doesn't need parentheses. And that's basically, if you have an if statement beforehand, you can say, if blah, 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 then execute blah, blah, blah. But you can also say else, which basically means otherwise execute this. So in all other cases, execute this. And that's what else does. There's also else if, and else if basically is for chaining those kinds of things together, so you can control the order in which things are checked. So you can say if something, then execute this. Otherwise, if this, then execute this. It's basically the same as nesting an if statement inside of an else statement, but else if just makes that cleaner, and it just makes it a little nicer. Conditional statements are especially really useful for error handling. So if the user gives you an invalid input, then that's one way that you can handle that, is with if statements. And they're essential to more complex programs. Programming as we know it would not exist without conditional statements. And that goes the same in FOOBAR. And then there's loops. You can see this roller coaster here is doing a loop. Loops allow you to repeat a section of your code a certain amount of times, and it will keep executing it, either for a certain amount of times or until a condition is met. And those are two different kinds of loops. you call a loop in FOOBAR by using the loop keyword, but you can see there's a certain amount of types and condition is met. That certain amount of types one is a for loop. So you say loop for, and then in the parentheses, you put an integer, which is the amount of times that you'll loop for. So you can just say loop for 10, and it will just loop 10 times. That works. That's an integer literal. You can also input a variable in there. So you can say loop for number of times to loop. And maybe using the conditional statements, you can dynamically change that number of times to loop depending on something else that happened beforehand in your program. And then there's loop until, which loops until a condition is met. So loop until A equals B. You can functionally say to loop forever if you say loop until false, because what loop until is checking for is it's going to loop until what's in the parentheses is true. So if you say loop until false, well, I don't really know when false is going to become true, but I don't think it's going to be anytime soon. So yeah, it's going to loop forever because false will never equal true. You usually don't want to have forever loops in your code, though. You usually want to loop until something happens because you don't really want to force the user to have to close your program by closing out of the terminal. You usually want some sort of, exit point. This is an important thing. Remember I was talking about how if statements can help you determine errors or invalid user input. One thing we didn't test last time, and we can do it when we do the live coding, is if you're scanning for an integer, what if your user types hello? Well, what you're actually going to get is this, and this is called the negative signed integer limit. So I mentioned in the last episode that integers are 32-bit, and specifically there's signed 32-bit integers, and the lower bound for signed 32-bit integers is this value right here, negative 2,147,483,648. This is what is called a sentinel value. And it is what is returned when there is an invalid integer. Any invalid input for an integer, when you're doing scan integer, it's going to save as this number here. So you can use this number to detect when the user has put in an invalid input. Unless they did actually put in negative 2,147,000, this whole thing, but in that case you'd want to use those long integer and long float like I defined in the last episode. We're going to assume that's not a problem for now. Alright, so here we are back in Visual Studio Code with that Is It 9 program that we wrote in the last episode. I finally changed the name from adder, but you can see it's still the same thing. If we compile, whoops, spoiler. But if we go ahead and we /compile.sh, we say is it 9.foob, and we run it, it will do the same thing it did before. So if I say 6, the presumption that the number which you have entered is 9 is utterly false. And we go /, is it 9, and I say 9, the presumption that the number which you have entered is 9 is utterly true. The problem with this program, it works, but we're not really doing, we're just inserting a Boolean into this sentence, right? We're not actually checking conditionally whether the number is 9. Yeah, we just have a Boolean here, and we're putting that into the sentence whether the number is 9 or not. That works fine for this program, but what if we wanted to do something else with our program? What if the program wanted to coerce us into giving it 9, and it wouldn't let us go until we entered 9? Well, there's no way to do that with this, but if we use the loops and conditional statements that I just went over, we can. So let's go ahead. We're going to delete everything up to here. So we'll keep our return true. We'll keep this number to be checked thing. And we're going to say loop until number to be checked is equal to 9. We'll open up our curly braces here. And let's copy this scan here. Let's put it inside of the loop. So this is going to have us keep entering values until one of them is 9, and then it will end the program. That's fine. That works for now. So let's go compile.sh. Let's just test that works at least. Is it 9.foob? Run. If If I enter 2 and 3s, and if I enter 10 and this giant number, yeah, it's not letting us go. But if we enter 9, then the program ends. Well, that's pretty nice. But what if, say, we wanted to actually, have it print something and have it give us a dynamic response depending on what we enter? Well, we can keep this basic loop here, but let's add an if statement, and let's say if number to be checked is in fact equal to 9, then basically these curly braces basically mean then, because they're what's going to be executed if this if statement is true. If number to be checked equals 9, then let's print the number which you have entered is in fact 9. Congratulations. And then let's say else, so in all other scenarios, in all other cases, we're going to print not this, but we're going to say try again, buddy. All right, let's see what happens when I compile and run this. Is it 9.foob? Enter a number. 3. Try again, buddy. 100. Try again, buddy. -9. Try again, buddy. 9. The number which you have entered is, in fact, 9. Congratulations. Well, all right, but what if I wanted to implement when you enter 8 or 10, it gives you a passive-aggressive message about you being really close to 9, but not quite there. All right, well, we can use else if to do that. So we say if the number is 9, then print this. Otherwise, if this, then do this. And then in all other cases, say try again, buddy. So we'll say else if number to be checked is equal to 8. And then here, I'm going to put this in parentheses with logic. This is kind of a good practice. And then I'm going to say v, which means or. Number to be checked is equal to 10. With logic, the kind of order of operations is a little bit finicky, so you want to make sure that you have full comparisons in each of the parentheses, and only then you add your logic operator. But if basically all I'm saying here is if number to be checked is equal to 8 or number to be checked is equal to 10, well, then we want to print something else. So let's grab ourselves another print, and then we're going to say so close yet so far with a ellipsis, because ellipses are very passive-aggressive. You'll know that if you've ever texted your grandparents. All right, compile, and we will say is it 9.foob. There we go. Let's run it. Enter number 4. Try again, buddy. 6. Try again, buddy. 100. Try again, buddy. 8. So close, yet so far. 7, try again, buddy. 10, so close, yet so far. 9, the number which you have entered is, in fact, 9. Congratulations. So using our loops and our conditional statements, that made that a lot easier. And we used if, and else here, and we also used our loop until. Of course, let me open up another document here, and let's select FOOBAR. That's not the only kind of loop. We did use all of the conditional statements. We didn't use all the loops. There's also loop 4. So I can say loop for 10. And then we will just, in this if statement, or not if statement, in this loop, we will say print I am looping. Looper.foob. And we do /compile.sh, looper.foob, run looper, I'm looping, and it prints it 10 times. So that will loop thusly. You can also do the kind of stuff like where you, in this function, you define an integer called index, for example. This is kind of just like the standard name for this sort of thing. And then I am looping, and let's add a space, and we say plus index. We should actually define a value for this. So we'll initialize it at 1. But I am looping 1, and then what we'll do with each loop is we will increment index by 1. So now if we compile and run this, looper, .foob, that's what I'm looking for. Uh-oh. Aha! I made a classic type conversion error. This needs to be to string. Let's try that again. Looper.foob. There we go. Run it. I'm looping 1, I'm looping 2, I'm looping 3, 4, 5, 6, 7, 8, 9, 10. Gives you an idea of how the for loop works, right? If we go back to our parrot program here, oh, that's the executable, but the parrot, we say, I'm a parrot, squawk. Oh, it's got a comment. Very nice. But right now, this parrot only repeats one phrase back at you, and he goes away. Usually parrots stick around and they repeat a lot of stuff back at you. So let's find a way to implement that using our loops. So what we'll do here, we still want a way for the user to escape. So maybe there's one word that the parrot will stop at, and maybe that word is stop. I'm a parrot, squawk. I won't stop until you tell me to. All right. So we have our string repeated phrase here. That's all good. Repeated phrase is equal to console.scan, and then console.print repeated phrase. This is okay. So let's say loop until. We'll take this, cut and paste it into here. Make sure that's properly indented. I like to have my curly braces on a new line as well. I don't really like it in that inline sort of format. But we'll keep this, and then we want our condition to be something. So we will say until repeated phrase is equal to the literal stop, which is all lowercase for ease of use there. So let's go ahead and let's do that. And we will say compile.sh parrot.foob. I'm a parrot, squawk. I won't stop until you tell me to. Hello, parrot. Hello, parrot. How has your day been? How has your day been? Stop. And then it says stop, but it also stops the program. We could find a way to stop that behavior, but I'm pretty satisfied with that. One last thing to go over before we get into your practice. Let's go back to, I don't know. We'll say, is it 9 here? And we'll add one last behavior to it. So currently, as is it 9 stands. Oh, whoops, no, that's not what I meant to do. I meant to open the terminal. So let's clear. If I go /is it 9, and if I enter hello, it will say try again, buddy, because negative whatever 2 billion is not 9. But if I wanted to, I could go ahead and have built-in error handling. First, I actually need to get that number, so I actually am going to do that with FOOBAR. So let's go select language, FOOBAR, and we will have, actually, let's modify our parrot here real quick. Instead of having him repeat a phrase, we'll have it repeat a number, and we'll say repeated number. Loop until repeated number is equal to, I don't know, 3. That will be our escape point. But console.scan integer. Whoa. Sorry. Ugh. Some of the code snippets can be a little cumbersome. But repeated number is equal to console.scan integer. And we will say console.print integer. And then we'll say repeated number. Okay. So now if I go ahead and I go... Oh, it's still stuck in this. 9. There we go. That's how I get out. /compile.sh. And we go parrot.foob. Oh, there's a parentheses somewhere. Aha. That was stuck over from the code snippet. Parrot.foob.
A few moments later.
Aha, I see the problem here. This is a string literal, not an integer literal. That was very silly of me to put that in double quotes. Okay. That's kind of a dumb problem, but yeah, that was just me being the absent-minded professor that I am. Parrot.foob, yeah, now it compiles successfully. So if we go ahead and run it, I'm a parrot, I won't stop until you tell me to, or specifically, I won't stop until you tell me 3, which is what I hard-coded in for some reason. But if I say 4, it will say 4. If I say 10, it will say 10. If I say 1,000, it will say 1,000. If I say hello, it is going to say negative 2,147,000,000, blah, 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 blah. And if I say 3, it will stop. So now we have that value, and we go back to is it 9, and let's add another else if statement here. We say else if number to be checked is equal to this big ol' value. Then we can say print I said enter a number. All right, and now we'll go /compile.sh. Is it 9.foob? Would I like to run it now? Yes, enter a number. Hello, I said enter a number. 8, so close yet so far. 100, try again, buddy. 9, the number which you've entered is in fact 9. Congratulations. So, hopefully you've learned a lot about, negative signed integer limits and if and else statements and loop until and loop for loops. And hopefully with all that knowledge, we have a pretty hard practice, so hopefully you can get through it. All right, for your practice, it's going to be a little bit hard, but bear with it. Try your best to do it. All right, write a program that gets 6 integers from the user and prints the following. How many of those numbers are even and odd? How many of those numbers are positive, negative, and 0? And if the user enters a non-integer value, display an error and prompt the user to re-enter the value. So it even, no matter how many times they try and fail, you should still be getting 6 integers from them. So like if you have an error, that shouldn't cause the program to stop. It has to keep going. Try your best to do that. There will be a solution in the next episode, but give it your best shot.